All right, welcome to Mauer Club. I just wanted to start this meeting off first with a couple of announcements. We'll be announcing the CTF start next meeting, which should be on the sorry about that. 27th of April. And so that will have all kinds of challenges for it. So some network analysis stuff where you'll be looking at PCAPs and answering questions. Some JavaScript deobfuscation, PowerShell deobfuscation, and potentially some macros to look at as well. So keep an eye out for that because there will be prizes. And then we'll also be having a meeting on the 4th of May where we'll have a special PhD speaker coming. And so make sure to attend that as well. And so today I'll just be talking about analyzing PCAPs with Brim and Wireshark. And let me just share my screen here. My bad. All right, so Brim is a security tool that's free, open source, and you can download it on your desktop for Mac, Linux, and Windows. And it can be utilized to perform quick analysis of different kinds of PCAPs and get a good overview of what is occurring in that network capture. And it utilizes data lakes, which are a repository that is centralized and can be used to store structured and unstructured data at any scale. And the type of data lake used in Brim is known as a Zed data lake, and it allows us to do lightweight searching and analytics for data that's structured differently. The Zed language that they created for it is described as a rich query language. So if any of you guys are familiar with the ELK stack, it's a lot like that, and it can be used to perform intuitive and simple searches. There's many different filters that can be used and created, pipelines and analytics that can all be utilized as well. In the data format that Brim actually stores all of that in is called the ZNG data format. It is a richly typed data format and embeds its type schemas in the data stream itself. So what it actually does is it processes the full PCAP and saves it in a completely different file type and then embeds those different schemas. So like, it's kind of like Wireshark columns, you know, like protocol and data frame and type. But then it actually attaches that to it instead of reloading it every time. Zed, Python, and TShark can all be utilized together, which can really speed up different types of workflow. And managing the data with Zed and Python is much easier than just hand going through it every time. And to use Brim, why use it is it indexes PCAPs much faster than Wireshark actually does. But at the same time, Wireshark is really great for going much more in depth in the PCAPs. So it's super easy to pivot from Brim to Wireshark. You can also create your own custom search terms and pin those, and it's much more easier and robust to query those PCAP files. And it also connects to VirusTotal for IP and URL searching and does file hash searching as well. It's just much easier to view that packet data, and Wireshark is much slower to load that packet data. So jumping into it, we're going to look at a PCAP that I did a quick analysis of that uses zloader and Raccoon Stealer. So zloader was originally a small loader that loaded a banking Trojan, but now it's evolved into something much larger and basically a full-fledged malware of its own. There's different variations of it that have been known to steal cookies and passwords, disable Windows Defender, and sometimes will rely on living off the land using binaries and scripts to evade detection. Some of them have also been known to just drop its own custom version of ransomware as well. So it's basically can do anything that any other type can do as well. In this specific instance, it's paired with Raccoon Stealer, which collects passwords, cookies, and other valuable information like autofill information from all the popular browsers, systems, and desktops. it can even detect and steal those cryptocurrency wallets. So here's an example query. It's just looking, see, we've got on the far left side, the method is post, so this post request, and the cut cuts those specific type schema columns out to display them for you. So that Zed query language was initially inspired by the traditional Unix shell, which can utilize a pipeline pattern. And so you can see like the originating IP, the responding IP, the ports, the method, the status code. And then there's lots of operators that can be used in Brim as well. These are just a few of them. The search operator filters input based on a search expression and compares it to each input value. This is done by default in each query, so you don't actually have to put search in. It does it if you just don't pick any other type of operator to use. The cut operator will extract subsets of record fields into new records. The unique one, which will deduplicate adjacent values. So another cool thing about Brim is it's paired with Zeki and Suricata. So when you're looking at all those alerts and you don't want to see a flood of the same alert over and over and over again, you can just use unique and get a good overview of what's going on. And then drop will just drop fields from record values. I also included the links at the bottom that link directly to those operators. So this slideshow will be available on the Google Drive later. So this is another example Git. We're going to dive further into what's happening here later on in the slides, but just looking at it initially, you can see that there's a ton of different GET requests going out with different status codes coming back. So it's like a 301, which is moved permanently, I think, and then 502, which is a server couldn't be reached. And so it's going out for a PHP, an auto.bat, us.dll, and an admin.priv.exe, which are just like the top 4 suspicious file types ever being downloaded. But we also see that there's many different IPs that it's trying to grab from. So there's that GET request going after the same one over and over and over again, but at some points, different IPs as well. And this is where we can kind of punch down into Wireshark from Brim. And so looking at those multiple GET requests of the 502s and one successful request to what looks like Telegram itself. So it's telegram.org. It's got the logo and everything with different information stored. And then potentially some base 64 encoding present when you see those double equal signs over here. And then the actual response back from the server. And after that huge response, there's another GET request that then downloads that exe file, the MZ. So there are tons of request failures and error codes, which looks like it's either attempting to download multiple different types of payloads because each one that it branches off of has a different operation itself. But it just continues to get those just in case. And then the Wireshark request overview shows some of those as well. So at like end of vmd.com, it requests 3 different file types, which it just trying to persist, trying different files to see if they'll actually run on the system. So one initially did run on the system, which was the initial Z loader, and it's trying to get that second stage. And then there's that export HTTP object list. And so these were all eventually successfully downloaded to the computer. And so what's included in Brim is a ton of different things to improve that data handling and user experience. It was originally developed with security in mind, though, so it has Zeki and Suricata integrations. Zeke is a network security monitor, and Suricata is an open source threat detection engine that can act as an IDS or IPS. Right now, they're kind of expanding Brim so that it can handle all kinds of different data. They want it to kind of be like an open source big data handling application. So these are examples of the alerts that you can see. And so we've got like malware observed, Z-loader related domain, PowerShell user agent usage, Telegram mirror check-in, which are all great. Well, not on the computer itself, but great to see to hunt down further. And then you can even punch down further into those alerts in Brim to see different information like the source IP, the signature that actually alerted, what category that signature is in, and a ton of other information that's pulled from open source repositories online. So looking further into those downloaded files, another one it grabbed was a zip, and inside that grab, you can see that it's referring to like mails/outlook.txt and system info. So this could potentially be like a target, an obfuscated target list for Raccoon Stealer. And then continuing to look at it, you can see the rest of the file there, and then a response back from the server itself. So since this is coming from the client computer, since it's in red, it could even be just it trying to exfiltrate data. And looking at that virus total result for the IP that was referred to earlier, it is being flagged currently by some security vendors, but 6 out of 90 flags isn't too good. Like you could write a crappy hello world program in NIM and it'd probably alert on more than that. So it's not an immediate indicator of maliciousness just because it has a few alerts. But this is how easy it is in Brim to look it up on VirusTotal, is you just right click the destination IP and immediately it'll pop it up in a browser window. And so it's fully query based, so you can build anything from the ground up to refer to any of the data in those packets once it processes them. So you can even look at like specific user agents that are being used to see what they went out and grabbed. And then this is the behavior graph of that specific malware, which is huge. So that can lead us to believe most of the files that were downloaded were utilized, and some malware may use regular files in order to hide, but other times multiple payloads and tactics are strung out amongst many files just to try to get that persistence on the computer. And then connecting the alerts, the Suricata side by side with Brim and Wireshark enables us to quickly connect the dots and recognize what that malware is doing. And so we observe those domains that are related to the Z-loader over here, and then the potential Raccoon activity, which is the data exfil attempt, which might be that outlook.txt files and stuff like that, and then the command and control activity dependency download. And then that Raccoon alert activity tied back is that, like, it specifically is that base 64 encoded string that goes out, and then the obfuscated response back in. And then we've got that Racoon Check-In, which is the PowerShell agent usage followed by the Telegram mirror check-in, which is actually pretty interesting because I've been looking at quite a few PCAPs of 2022 from malwaretrafficanalysis.net. And this was the first one I actually saw using like open source sites, kind of, well, not open source, but publicly available as like check-ins to find the next C2 server if for some reason one gets seized or goes down. And here's that check-in just displayed, so you can see the proper headers and packet data inside there. This is legitimately going to telegram.org. And so Raccoon command and control communications needs several values to actually work. They need the main key, the URLs of the Telegram gates with the channel name, the bot ID hex string sent to C&C every time, and the Telegram key used to decrypt the C&C address that is grabbed from the Telegram gate. This is not stuff you can just directly see coming through on the packet capture. You can see the files coming through, but you actually have to download those and disassemble them to find where it's storing those keys to use there. Then looking further into that C&C, the main key is decrypted from running the program itself after unpacking it, so it won't be seen in network traffic most likely. The encoded and encrypted Telegram gate URL can be seen in the network traffic right down here, which is that response from the base 64 send out from the client computer. And I even went to it and it's still currently up. So Telegram hasn't taken it down or anything. And so it's still potentially getting actual command and control information from this Telegram gate. So the prefix of the key is normally 5 characters and the postfix is 6. So they get cut off, and then that reveals another base 64 encoded string that's also RC4 encrypted. And this is just further how it works. That Telegram key is used as a key to the RC4 algorithm used to decrypt the C&C URL, where Raccoon will then make a query string with the machine GUID and username along with the bot ID, and it encrypts the string with RC4 and the main key before encoding it with base 64. And that data is then sent using post to the C&C, and the response is base64 encoded and encrypted with the main key. And the Telegram infrastructure is used to store and update those command and control addresses for the malware. And for this specific malware campaign, there's been over 429 unique Telegram channels used that have been observed by, there's a vast, but there are tons of different things that can be looked out for this specific malware campaign as well, along with in-network traffic that I think is kind of unique because you don't run into some of these every day. But like heap spraying, for example, is a technique used in exploits to facilitate arbitrary code execution and attempts to deliver shellcode at a certain address in a specific application and takes advantage of the vulnerability in application. If you're seeing a packet that has just like raw, unencoded, unencrypted bytes that are being used for heap spraying, it's most likely targeting something that's being hosted online so that it can actually try to get like a remote shell on it potentially. So detecting that network attempt over network traffic will look like this. So that possible heap spray attempt for the Circata alert and then seeing it down there. And then there's also tons of legitimate services currently being used for posting bad things. We all know that malware authors like to host it on usually websites that compromised and just throw it in like the uploads folder there or something. But there are a lot of like fully legitimate sites that are currently hosting malware, like GitHub, Pastebin, OneDrive, Twitter, Telegram, and these can all, by extension, be used to store C2 information, those malicious files, and much more. And so this was one I observed in that PCAP, which is a legitimate file sharing site being abused. And since Circata alerted on it, it's been abused quite a bit in the past for it, which sucks because once I actually looked at it, it's a pretty fantastic file sharing site, and I'm probably going to be using it from now on. But it's a normal file sharing site where anybody, they don't have to log in, can just upload something, and then they get the URL, and they can just then encode it and store it in their malware to be used for later. And encoding and encrypting is really everything in the network traffic nowadays. So there's a bunch of stuff that's base64 encoded. Just to try and slip it past different areas. And once it's decoded, like this one, for example, you can see that there's a direct MZ file there. But different types of malware will now start taking extra steps and precautions like actual encryption so that it's not just this easy to detect or just looking for that base64. Like in the last PCAP where the base64, I was actually stored with extra bytes on the front and the end that then just got chopped off so it wouldn't immediately alert on it. And then that's the end of my presentation.
Yeah, question.
Oh, yeah.
Regular expressions in Brim, or is it just like terms?
You can use regular expressions. And that's also a really good way to catch up with base64. I was going to add that on to the end. Thank you for asking. But like just chopping the first and last bits off of base64 encoded malware shouldn't be enough. Most good regex terms will catch that, but like sometimes it just like slips by, like the bare minimum effort, you know.
Do you have Brim on here?
Yeah, I actually do. I can show.
Yeah. Just got a little bit extra time.
No problem at all.
Oh, there's also another question over there. Michael. You can ask your question.
Oh, sorry.
I was wondering, does Brim have the ability to automatically decode base64 or other coding types, or decrypt those things, or well, I guess it would be decode, but does it have that ability?
So you can do that if you want it to. So you can create those custom queries to decode that kind of stuff. You can also utilize that Python extension that comes default with it. You can just, because every time you start up Brim, it actually starts a server on your computer to be used. So you can use an API key to access that server on your client and start running those custom queries to, by default, like decode base64 and repeat that captures and assign it specific type schemas or alerts and stuff like that. So you can even have a custom call on a data overview where there is data like that that's then decoded. It's fully open source, so it's really the possibilities are endless. Just like whatever you can code, you can put on this. But so these are actually pretty big PCAP captures, and I just wanted to show this real quick because most of the time loading these in Wireshark would take on my old computer probably a couple of minutes or something. But since these are stored in the data pools here, you can just click on it and it basically has it all ready to be queried right here already. And so, for example, Brim comes with a bunch of queries that are here by default, show all kinds of different data. So there's an activity overview that you can see. So there's a bunch of SSLs being used, which was kind of hard for this presentation because in 2022, a lot of malware is now using HTTPS, which makes it a lot harder to see what's actually going on in those packets. But then there's also HTTP being used. There's even like the weird category and the PE category. So successful PEs being downloaded. And then unique DNS queries out here where you can quickly refer to them. And if you really wanted like to set up another custom query, you could automatically have these parsed and compared against VirusTotal or any other open source information for malicious URLs. Then here's some of those unique HTTP requests where you can see, you guys see this? Yeah, all right. You can see like different .dat files being downloaded, a zip, and normal Windows updates. And then here are some like file activities downloads. And I have a custom alert overview that I use here that they just updated this, so I haven't fixed it yet, but there's a bunch of like errors here. So abuse possible, Drydex. This is Quackbot with Cobalt, so at least it's alerting on something, I guess. But if you come down, you can see that it's like QBot style SSL certificate. And yeah, reported C&C server groups. So the Surcata rules that it's referring to are always being constantly updated by a dedicated community of people that are nice enough basically to just keep updating those open source areas. But yeah, that's basically Brim.
Any other questions for him?
What was the file transfer site you found? Was the file that was used?
Transfer.sh. It's actually super handy. And if I'm not wrong, I'm pretty sure they do legitimately encrypt. It's open source, so you can see if they do it or not, but they encrypt every file they get on their own servers and stuff. So it's like a public utility essentially at this point. Yeah, no problem. I just like it because you don't have to log in all the time. All right, well, we've got Zaki here. Who
And
is,
also before that,
yeah, no problem.
And Evan has been working very hard on a CTF, and he's prepared many challenges, and a lot of them deal with network activity. So it's possible you could use Brim to possibly solve some of those. Is that right?
Oh yeah, totally.
So
I would highly recommend using them on some of the CTFs. They will cut down on a lot of time, especially on the harder ones that have some like weird questions you probably haven't run into before.
and right now we have about, I think, 300 or so, maybe 350 left in our budget, and we are trying to see if we can spend that all on prizes and stuff. We don't know for sure yet. So if we can, we'll try to put that all into the CTF. Right now, I think we're going to transition to Zaki. It may take a minute or two to get things set up. So maybe have a brief intermission if you want to chat amongst yourselves.
Yeah, hello everyone. My name is Zaki Ahmed, and wait, it's working out. For my introduction, like I'm doing my information system, a master's in information systems, and I have a bachelor's degree in computer science, and currently working as a research assistant at Aurora Labs. And my topic is zero trust security. Zero trust security is a concept. It's a state of mind in response to weakness of current network security solution. The zero trust model follows the idea that no network, whether internal or external, is trustworthy. And zero trust is basically an evolving security model that moves defense from static network-based perimeter to focus on user, assets, and resources. The fundamental purpose of zero trust is to understand and control how user processes and devices engage with data. But zero trust is certainly not a firewall or some next generation perimeter or a VPN. Zero trust means like to never trust, always verify, and assume breach all the time. So yeah, the purpose of zero trust is simple. Today's enterprise infrastructure has grown very complex due to the several internal networks and multiple entry points. Because of that, perimeter-based network security has become insufficient. And once the attacker breaches the perimeter, further lateral movement is unhindered. So this led to development of zero trust. On the need of zero trust architecture, why we need ZTA is because the concept of a network-based security perimeter is like old-fashioned, outmoded. We need better concept like ZTA, where we assume breach all the time and no user and devices are given special access inside our network. And zero trust is where it gives you a reality check that hackers are hiding inside our network and malware goes undetected for months or some case years. Our old security system uses a trust but verify approach, but zero trust uses never trust, always verify approach by doing multi-factor authentication and continuous verification. It prevents lateral movement and it limits and prevents data breaches. So it features focuses on applications, data, users, and the identity of the user or subject by providing limited access, like least privilege. It inspects and log all traffic and micro-segmentation of network, and all network sessions be authenticated and authorized, and all network traffic are encrypted in ZTA. Advantages of ZTA is like apps and data can be accessed anywhere, regardless of the location. There's a centralized view of security visibility, using an easily used device of their own choice, single sign-on, and context-aware enforcement of policy. The history timeline, like the term zero trust was first used in 1994 by a scholar named Stephen Paul Marsh as part of his research, and then in 2004, Jericho Forum defined and promoted deperimeterization. It's basically protecting an organization system and data on multiple levels by using mixture of encryption protocols and data level authentication. Later, it was popularized around 2010 by John Kinderberg. Marsh, he first mentioned zero trust in his scholarly article, formalizing trust as computational concept. It argues that trust is a means for understanding and adapting to the complexity of the environment, a means of providing added robustness to independent agents, a useful judgment in light of experience of the behavior of others. John Kinderberg, he basically polarized the term zero trust. He was a Forrester research analyst who later coined the term in 2010, and he follows the motto "Never trust, always verify." His his breaking point of view was based on assumption that risk is an inherent factor both inside and outside the network. History of zero trust. The concept of zero trust existed in federal government even before the term zero trust was conceived. Like in Department of Defense Black Hole, the change from perimeter-based security to security based on individual transaction. Then Jericho Forum in 2004 made public the concept of deperimeterization, which limits the trust based on network location and limit reliance on static defense for a part of network. Later, this concept was evolved into zero trust. Federal agencies like with zero trust ideas are they have moved to security based on zero trust principles from more than a decade, building capabilities and policies such as Federal Information Modernization Act, followed by Risk Management Framework, and so on. When these programs were started, they were limited by technical capabilities. Security policies were largely static and were enforced at large choke points that an enterprise could control. As technology matures, it becomes possible to continually analyze and evaluate access requests in a dynamic and granular fashion to a need to access basis to mitigate data exposure. Fundamentals of zero trust. Zero trust focuses on protection of data. Like data must be always secure all the time. It treats all hosts as they were accessible beyond the and key goals of ZT are to provide least privilege access, and there should be total visibility and authentication authorization upheld and enforced continuously. And zero trust is more about the identity of the unique request, who is sending the request. Basics of zero trust is that data is king. The data must always be protected. All devices must be known and discoverable. Policy must explicitly indicate what should be done with data, users, devices flow in every context. And implementation of policy must be dynamic, and implementation of policies must be context aware, like different circumstances have different results. And least privilege. Least privilege, it's a concept in computer security that limits user access right to only what are strictly required to do their job. Users are granted permissions to read, write, or execute and the files, free sources necessary to do their job. Like access to data is not universally granted. It is given on need-to-know basis based on the individual unique needs. And different behavior may trigger checks like multi-factor authentication. And tenets of ZTA, the main principles all data source and computing services are considered resources. All communication is secured regardless of network location. Access to resource is granted on per session basis and is determined by dynamic policies, and authentication and authorization are also dynamic in this. And all traffic and access requests are logged and used to enhance existing access policies. Encryption. All content on the network should be encrypted before sending. All endpoints must ensure authentication and encryption. Only use the best and strongest form of encryption or authentication. For securing your assets, you can use mutual TLS. And with Windows, you can use IP inter-protocol security with domain isolation and can allow host-to-host encryption as well. Logical components of CTA, there are 3 components: policy engine, policy administrator, and policy enforcement point. Policy engine decides resource accesses, and policy admin manages the communication between requester and the requested source. And policy enforcement point act as a gateway which communicates with policy engine and policy admin to monitor, enable, or terminate connections to resources. Zero trust law. So control plane and data plane, like they form the core of the zero trust architecture. Control plane make the policy decision and data plane implement those decisions. Here, like the components to help to you see if the access is granted. To your left, like CDM systems, they provide data about assets and that make access request, and industry compliance system ensure that the policy tools developed are in response to industry standards. The threat intelligence feed provides information on threats. Activity log gives real-time feedback on security postures, and data access policies are rules that determine conditions where access may be granted to resources. And public key infrastructure, like they are responsible for generating and logging certificates. ID management are responsible for creating, storing, and managing user account and identity record. And CIM, security information and event management, stores security data for analysis. Logical variation on ZTA approaches, like there are many ways to enact a ZTA logically. The approaches include like enhanced identity governance, logical microsegmentation, and network-based segmentation. These approaches vary in component and policy rules. Each approach implements all the tenets of the ZTA. Enhanced identity governance. This approach uses the identity of user as the key component of policy creation. The primary requirement of for resource access is based on access privileges granted to the given subject. Factors such as device use, asset status, and environmental factors may grant only partial access to resource based on location. Microsegmentation, in this approach, resources are placed on microsegments, each protected by a gateway. Next generation firewall, like they act as policy enforcement points to protect each microsegment, and gateway act as policy enforcement points to grant permission or deny it. Variations on ZTA. ZTA basically introduce a barrier between requester and the resource itself. So there are like three variations: device management, device agent, and gateway model. And this, like each asset has a device agent, as you can see there, and each resource has a gateway, and gateway serves as a proxy for resource. Agent directs request to policy enforcement point for evaluation, and gateway communicates with policy administrator. So this model requires excellent device management to not work it. Enclave gateway model. It is a variation of device agent gateway model where gateway may be located at boundary of a resource enclave. It is well suited for legacy applications, good for on-site data center, and useful for cloud microservices. And resource portal model. In this model, gateway portal can serve just one resource or an enclave. Policy enforcement point works as a gateway for access requests. Software component need not to be on client devices, and visibility over assets, and only when they are connected to a portal. It is well suited for legacy applications, and it's flexible for BYOD, bring your own device, and collaboration between enterprises. Trust algorithm. So this algorithm is a process used by policy engine to grant or deny access to resource. The policy engine takes input from multiple sources. The process can be grouped into broad categories and visualized as this. In this just input, access request is the actual request from the user, and user database and history. This is who that is requesting access to a resource, and resource policy and requirement are a set of policies that complements user ID and attributes database, and also define the minimum requirement for accessing the request. And asset database. This contains the status of each enterprise-owned assets, whether it's physical or virtual, and threat intelligence and logs. This is the information feed about general threats and active malware operating on the internet. So these values can be used to reflect the importance of the data source to an enterprise. Then the final determination of is then passed to the policy admin for execution. Trust. Trust is basically a human emotion, and machines don't have emotions, so machines are not worthy of blind trust. And similarly, like internal networks should not be trusted any other more than the internet, and because misplaced trust has catastrophic results and it invites countless attacks. Use of criteria versus scores for trust algorithm. A criteria-based trust algorithm, TA, assumes a set of qualified attributes that must be met before access is granted to a resource. A score-based TA computes a confidence levels based on value for every data source. If score is higher than the set level, access is granted. And singular versus like contextual TA. So a singular TA treats each request individually and does not take the subject history into consideration when making its evaluation. This can allow faster evaluation, but there is a risk that an attack can go undetected. And a contextual TA takes the subject's or network agent's recent history into consideration when evaluating access requests. A contextual TA, it is a more superior choice, and policy engine needs to have access to information on users and application. A policy enforcement point must detect and inform policy engines if there's anything. So trust in ZTA, trust is not given blindly, rather it is earned. So trust is a variable in ZTA that can change depending on the context. It adapts on certain user choices. So authentication of user is based on context. Sometimes device certificate is enough. And sometimes you have to do multi-factor authentication depending on the context. And context-aware policies can use trust scores to determine if additional authentication is needed. The user contradicts their history, like that is one condition, and the user tries to access a critical resource, that is one condition. To trust a device in GTA, you can use device certificates to authenticate the device. You can revoke those certificates if the device is stolen or lost. If user does not follow the usual pattern or usual behavior, we can re-authenticate the user, re-establish the trust. Network components of ZTA, like communication flow should be separated, like control plane for network control communication and data plane for application or server communication. Network requirement of ZTA, like resources can only be accessed through policy enforcement point. Data plane and control plane should be logically separated, and assets must have network connectivity, and remote assets can access resources without network infrastructure. All network traffic should be monitored, and your network should be scalable enough. And you must use credential to see assets and their security status. Challenges of having ZTA can be a loophole in the system which is unknown to the user and can be exploited by the hacker. And a more good approach is a hybrid approach where you have the zero trust and a legacy system too. And one of the main challenges is also cost for implementing ZTA can be very high, so companies may back down from implementing, and it also needs to be maintained and updated on a regular basis based on policies laid by the company. And by verifying every request sent to the system, the ZTA will delay the average traditional system like request handling time, and that can easily result in system downtime. So those are the challenges. And if you want to know more about how to deploy it, how to migrate ZTA, you can refer to NIST SP 8200 to 207 for more information. And that's it. Thank you.
Great job, Zaki. One thing that I'd like to mention is I've been to various conferences in person, remotely over the last year or two. And one thing that is very, very common is people were talking about zero trust security. Zero trust security is something that's not really ready for prime time yet, but the federal government wants us to move to zero trust security. There's a big impetus for that, and lots of people are talking about it. I've heard people talking about it at conferences just amongst themselves. There are talks devoted to it. So it's a very, very hot topic, trendy topic that I think a lot of you, if you're working in cybersecurity, will be dealing with it at some point in the future. So it's good to get an excellent introduction from Zaki. Do we have any questions for Zaki on zero trust? Back there?
Sorry?
Yes.
Sorry.
Yes.
Yeah, there is one in the NIST risk management document. It says that there's an Aston standard where you have to maintain. There are like 2 or 3 more models that you have to refer. Don't have the like full detailed version of it. You might have to. Sorry, you have to go and refer online. Sorry for that.
And I actually was whispering in his ear to tell him to say it about NIST. But so NIST does talk about that, but I think I may have kind of misled him a little bit. The problem with that is, and I know to a large extent, there really is not standardization. Different companies have different competing products out there. And so it's kind of the Wild West. NIST is trying to do some stuff, excuse me, but there still isn't a standard, and that is an open problem. Other questions?
Okay.
All right, well, if we don't have any more questions, then we can conclude this. If you want to sign in, I'll have a sign up sheet up front in a second. All right, thank you.